Imagine a date etched in cosmic history, July 12, 2038, a day that could be marked by an event of unprecedented magnitude. Now, picture an asteroid, a celestial wanderer hurtling through space on a collision course with Earth. This isn't just any asteroid, it's a massive rock, traveling at unimaginable speeds. The odds? A chilling 72% chance of impact. This figure isn't plucked from thin air. It's the result of meticulous calculations by some of the brightest minds in astrophysics. This isn't science fiction. This is the stark scenario that NASA grappled with in a recent planetary defense exercise, a sobering reminder of the cosmic threats lurking just beyond our atmosphere. These exercises are crucial, as they help us prepare for the worst-case scenarios. The scenario, though hypothetical, underscores a critical point. It serves as a wake-up call, highlighting the importance of vigilance and preparedness. We live in a cosmic shooting gallery. Our planet is constantly bombarded by space debris, some of which are large enough to cause significant damage. Asteroids, remnants from the early solar system, constantly crisscross Earth's orbit. These ancient rocks are like time capsules, holding secrets from the dawn of our solar system. Most are harmless, burning up as meteors in our atmosphere. These shooting stars are a beautiful reminder of the vastness of space. But some, like the ones simulated in the exercise, are large enough to pose an existential threat. These are the ones that keep scientists up at night, as they could potentially wipe out entire cities or even civilizations. The 72% figure, while alarming, is not a prediction. It's a calculated risk, a statistical probability that underscores the need for constant vigilance. It's a calculated risk, a reminder that our understanding of these celestial threats is constantly evolving. As our technology and knowledge improve, so does our ability to predict and potentially mitigate these threats. But even a small chance of impact is a chance we can't afford to ignore. The potential consequences are too dire to be complacent. The question isn't if, but when, the next big asteroid will come knocking. History has shown us that these events are not just possible but inevitable. And when it does, will we be ready? The time to prepare is now, not when the asteroid is already on its way. Our survival may depend on it. In the face of potential cosmic calamities, knowledge is our greatest weapon. The universe is vast and unpredictable, and while the chances of a catastrophic asteroid impact are low, the consequences could be devastating. Therefore, preparation is key. To prepare for the unexpected, NASA recently assembled a team of experts for a high-stakes simulation, the Planetary Defense Interagency Tabletop Exercise. This exercise is not just a routine drill, it is a critical component of our planetary defense strategy. This exercise brought together scientists, engineers, and policymakers from various government agencies and international partners. The collaboration was essential, as planetary defense is a global concern that transcends borders and requires a unified effort. Their mission? To confront a simulated asteroid threat, assess the risks, and formulate a coordinated response. The scenario was designed to be as realistic as possible, challenging the team to think on their feet and adapt to evolving situations. Over the course of several days, the team wrestled with a cascade of hypothetical challenges. These included unexpected changes in the asteroid's trajectory, potential communication breakdowns, and the need for rapid decision-making under pressure. They analyzed the asteroid's trajectory, estimated the potential impact zone, and devised strategies to mitigate the damage. This involved complex calculations and simulations to predict the asteroid's path and the potential consequences of an impact. The exercise wasn't about finding the right answers, it was about asking the tough questions that would help refine our strategies and improve our preparedness. It was about asking the tough questions. What if the asteroid's path changes unexpectedly? How do we ensure that all relevant parties are informed and coordinated? What are the limits of our current technology? Can we develop new technologies to better detect and deflect potential threats? These are critical questions that need to be addressed. How effectively can we communicate the threat to the public? Public awareness and understanding are crucial in ensuring that people know how to respond in the event of an actual threat. And how can we collaborate internationally to mount a coordinated response? Planetary defense is a shared responsibility, and international cooperation is vital in pooling resources, knowledge, and expertise to protect our planet from potential cosmic threats. The exercise, while fictional, yielded valuable insights into our planetary defense readiness. One key takeaway was the importance of early detection. The earlier we identify a potential threat, the more time we have to develop and deploy countermeasures. This underscores the critical need for robust asteroid detection and tracking systems. Another crucial insight involved communication. In the event of a real asteroid threat, clear, accurate, and timely information would be paramount. The exercise highlighted the need for effective communication strategies to inform the public without causing widespread panic. Perhaps the most sobering realization from the exercise was the sheer complexity of the challenge. Deflecting an asteroid is not a Hollywood movie plot. It's a multifaceted problem that demands expertise from various fields, including astrophysics, aerospace engineering, and international diplomacy. While the exercise showcased the dedication and ingenuity of our planetary defenders, it also exposed vulnerabilities in our global readiness. One glaring gap is our limited capacity for rapid response. Currently, we lack the infrastructure and technology to quickly deploy a deflection mission in the event of an imminent threat. The exercise also revealed deficiencies in our ability to accurately predict an asteroid's behavior. Factors like an asteroid's composition, rotation, and potential for fragmentation can significantly influence its trajectory and impact. Improving our understanding of these variables is crucial for developing effective deflection strategies. The exercise served as a stark reminder that planetary defense is not solely a NASA responsibility. It's a global challenge that demands international cooperation. Sharing data, coordinating resources, and developing unified response protocols are essential for effectively addressing this shared threat to humanity. Fortunately, NASA isn't sitting idly by. The agency is actively developing and testing planetary defense technologies, one of the most promising being the Double Asteroid Redirection Test, or DART. This mission is straight out of science fiction, but with a real-world purpose. DART's mission was to test a kinetic impactor, essentially a high-speed spacecraft designed to slam into an asteroid and alter its course. The target Dimorphos, a small moonlet orbiting a larger asteroid called Didymos. In 2022, DART successfully smashed into Dimorphos, marking humanity's first attempt at deflecting a celestial object. The results were astounding. DART's impact significantly altered Dimorphos's orbit, proving that kinetic impactors could be a viable defense against asteroid threats. This mission was a resounding success for planetary defense, demonstrating that we have the technology to nudge asteroids off a collision course. Detecting potential threats is just as crucial as deflecting them. To bolster our early warning system, NASA is developing the NEO Surveyor, a space telescope designed specifically to hunt for near-Earth objects, including potentially hazardous asteroids. The NEO Surveyor will scan the skies in infrared light, which is ideal for detecting the heat signatures of asteroids against the cold backdrop of space. This will allow us to discover and track asteroids that are currently hidden from view, including those lurking in the glare of the sun. By identifying potential threats early on, the NEO Surveyor will buy us precious time to develop and deploy countermeasures. This project represents a vital step in our efforts to catalog and understand the population of near-Earth objects, allowing us to better assess and mitigate the risks they pose. The 72% chance of an asteroid impact in 2038 may be a hypothetical scenario, but it serves as a stark reminder of our vulnerability in the cosmic shooting gallery. Our planet, a small blue dot in the vast expanse of space, is constantly under threat from these celestial wanderers. The vastness of space may seem indifferent to our existence, stretching out in all directions, seemingly infinite and unchanging. But amidst the celestial ballet, there are real dangers lurking. Asteroids, comets, and other space debris move through the cosmos, sometimes on a collision course with Earth. Yet we are not powerless. Humanity has always risen to challenges, and this is no different. Through scientific ingenuity, technological innovation, and international collaboration, we are developing ways to detect and deflect these potential threats. We can develop the tools and strategies to protect our planet from cosmic threats. From early warning systems to advanced deflection techniques, our arsenal is growing. The DART mission and the NEO Surveyor project are testaments to our commitment to planetary defense. These initiatives represent the cutting edge of our efforts to monitor and mitigate asteroid threats. As we peer into the cosmos, we are no longer passive observers. We are actively seeking out potential dangers and devising ways to counter them. We are becoming guardians of our own destiny, taking proactive steps to ensure our survival. We are developing the means to deflect asteroids and safeguard our planet for future generations. This is not just about survival, but about thriving in the face of adversity. The cosmos may throw us curveballs, unexpected events that challenge our very existence, but we are learning to swing back, to adapt and overcome these challenges, armed with knowledge, innovation, and a determination to ensure that humanity's journey continues uninterrupted amongst the stars. Our efforts today will pave the way for a safer, more secure future. We are not just protecting our planet, we are ensuring that future generations can look up at the night sky with wonder, knowing that we have taken steps to protect our home in the vast cosmic shooting gallery.